No, you're fine. You're fine. I'm not changing anything. I'm just changing it the way I talked, the way I said things. Don't worry about it. I'm not changing anything. So we're going to be going with the simplifying rational expressions. If you guys remember on the last one, I just said monomials, which I was going to add in before, but I'm not going to include that. So we're just going to be using rational expressions by using the rules of exponents. So the first important thing that I want to make sure that you guys understand is what exactly are the rules of exponents. Now, there's a couple different things we need to understand with the rules of exponents. First of all, if I was going to say 3 times 3, we could say that answer is going to be 9, right? But we could also rewrite this. If I just wanted to rewrite this, I could also rewrite this as 3 squared. Would everybody agree with me? And yes, we know the answer is 9, right? Well, what would I do with 3 times 3 times 3? That would be 3 to the third power. So you guys understand how many 3's you write up there. No. OK, you see, that's fine. How many 3's you write up there, that's going to go ahead and be the power, correct? So basically what I want you guys to understand is there's little 3 to the 1 power. Do you guys understand that 3 to the first power is just equal to 3? Yes? So basically with every number, you can always have a power up there. So when we look at this, basically what I'm doing is 3 to the 1 plus 1 plus 1 power equals 3 to the third. So what I want you to understand is the rules of exponents state when you are multiplying exponents, that means they have the same base with a power, then you simply add the powers. OK? Now, this is important because this makes sense with numbers. But what does it work with when I use fractions? Well, obviously, ladies and gentlemen, or not fractions, variables. X times x, you guys should know, is x squared. It's not 2x. X plus x would be 2x. So the same thing by using these rules of exponents. If I say x to the third times x squared, do those have the same base? Yes. So if I want to go ahead and find the value of, or if I want to simplify this expression, I would simply add the powers, and I would obtain x to the fifth. Does everybody follow me with this? OK. Now, so let me write it this way. X to the 3 plus 2, which equals x to the fifth. These are all things that I expect to see on that sheet of paper for you guys, because we will be coming back. I want you guys to keep all these sheets of paper. Lizzie, you have a sheet of paper right behind you. You guys are going to be keeping these. And I might tell you, I might allow you to use some of these at some point when you are taking this. So it might be advised, even if you think you remember this stuff, to write it down so you have access to this information. Because what if you just forget? You're like, oh, you have what we call like the brain fart, right? Like, oh, it's a test now. It's all stressful. I forget. Do you add or you multiply them? What do you do? So if you guys can write this down, you now have access to all of this information. OK? Because you might be allowed to use it. You might not. I don't know yet. But why take the risk of not writing it down if it's not something that you're like automatically remember? So the first rule of exponent that I want to get with you is what we call the product rule. And basically just what the product rule says, if I have x to the m times x to the n, that equals x to the m plus n. Does everybody follow me with that? Yes? Can I start erasing the 3's? No, I'm still waiting on you? OK. So let's go. I guess I'll just do the next one below it, so while some people can still write. So the next thing I'd like to talk about is division. And if you guys obviously know that 3 divided by 3 is equal to what? 3 divided by 3 is equal to 1. Everybody agrees with me on that? Yes? So what the product rule states is, let's go, again, let's think about this, right? And let's do 3 times 3 times 3 times 3 divided by 3 times 3. Now, using the product rule, this is really the same thing as 3 to the fourth power divided by 3 squared, right? Now, if you guys just look at this, though, by 3 divided by 3, you know the 3's are going to divide out, right? Or they divide to 1. So really, that's 1, that's 1. So you have 1 times 3 times 3. So what's left over? Just 3. I know, but just think of it as with exponents. 3 squared. Basically, what I want you guys to understand, back Camille. Basically, what I want you guys to understand, your question?
Oh, so it's kind of like 3 divided like 4 or 2.
So, well, you're not really dividing. What you're actually doing, which I didn't pick good numbers for and two I shouldn't have used, but basically what you're doing is you're subtracting the numbers. So I don't want you to divide the exponents. I want you to subtract. So the next rule, which is what we call the quotient, states if you have x to the m divided by x to the n, that equals x to the m minus n. Subtract them. Can I erase the product of these? All right. And we only have one more to go. And let's pretend I have, now let's use some x's. Let's say I have x times x over x times x times x. Really, guys, this is x squared divided by x cubed. Would everybody agree with me? OK. Now, using the rules of exponents, Faith, what do I do with my powers when I'm dividing? I subtract. I get x to the negative 1. OK? Now, let's use what we did over here by where we divide them to 1. Does everybody agree with me that x divided by x goes to 1? Yes? Also, this x divided by that x goes to 1. So therefore, I'm just left with an x in the denominator. So what I want you guys to understand is x to the negative power is equal to 1 over x to the m. Because in reality, this is really equal to 1 over x to the first power. Do you see that? If it's negative, it's really equal to it being in the denominator. Does everybody see that? Kind of. So think about when you have something negative, you're going to want to rewrite it in the denominator. And in the same case, or 1 over x to the negative m equals x to the m. So just think if it's negative, to write it as a positive power, you have to put it in the denominator. If it's negative in the denominator, to write it as a positive power, you have to put it in the numerator. Does that kind of make sense? You guys see what happens? So think about it. You guys can see where that goes with that. The last rule I just need to go with you guys. I'm not going to spend time going through it. But if you guys remember, anytime we take a power or we take an exponent and we raise it to a power of 0, that's just going to equal 1. OK? That's basically what we're going to be doing today. Mainly, you guys are going to be using division.